What do you guys see in terms of this aspect? It's pretty redundant to what we saw with the cerebellum, isn't it? Right? The reason why is simple. The basal nuclei is a pathway. It contains a red nucleus, right? It makes contact with other regions of the brain. One of the regions it makes contact with is the cerebellum, right? So it kind of makes sense why you see this redundancy. Right? And you use the kind of example that you have stimulatory and inhibitory effects. Stimulatory effects of the basal nuclei, you can cause the muscles to contract. At the same time, we don't think about the inhibitory part, right? So when you want a muscle to contract, that's all you think about, isn't it? I'm doing bicep curls, right? I want the arm to go up. Do you have to think about, relaxing the other side? No, all right? It's hard enough to really focus in on that movement, much less relax the other side. That happens naturally because of the basal nuclei. Right? The cerebellar comparator function is like the spinocerebellar system, right? And this is the name for what that system does. So when we talk about the spinocerebellar system bringing information in, right? Well, when it brings it in, it allows us to have this function. It compares intended versus actual movements. So then if I am going to throw a football, right? If I throw a football, if you see Aaron Rodgers throw a football, you see him 90% of the time, it's almost overhand. But every now and then, somebody's coming in at him, and he has to throw it sidearm, right? What happens? Well, he's comparing what his intended movement should be, and now he's getting visual stimuli that somebody's gonna block it. So if he throws it over the top, somebody's hand's gonna block it. So he starts to compare, and then he has to then change his throwing motion. So then it's more sidearm, right? It's kind of crazy how they're able to do that so quickly, right? But that's what makes him one of the best, right? So, and what makes him a multi-millionaire too, as being one of the best. So that's always a little add-on there. But that is sometimes a reason why no matter how much you train, right? Some people have usually even the same skills as he does, but the cerebellum in the certain people, right, are just different than in others. Right. Reticular activating, and then Wernicke's and Broca's, right? Reticular activating system is a system that is very global, right? It allows us to wake up. And if you take a look at it, it's actually found in the tegmentum area. And it receives information from everywhere, right? You guys have, obviously, auditory stimuli, if it's loud enough, can wake us up, right? If it's loud enough, it brings that information to the reticular activating system. The reticular activating system then allows you to wake up the brain, right? So think about an alarm clock, right? How about olfaction, right? Some people smell smoke and they'll wake up. Some people don't. You hear people dying when they've had right, in their bed because of the fact that they didn't wake up when the smoke alarm went, right? Other people wake up immediately. Seriously, we have different sensitivity to these, I'm saying, right? So also, right, some people really, the people like my brother, I'm not naming names, but, right, nothing can wake them up, literally, right? We actually have to sometimes, have somatosensory, push them to wake them up, yeah. Right? So that does happen. There are people who are such deep sleepers that even auditory, olfactory, and visual stimuli is not enough. Meaning what? You turn on the light when it's real dark. And most of us, when you're asleep, you turn on the light right away, right? It kind of has a tendency to wake you up, right? Well, some people, even that doesn't wake them up. You actually have to go in there and push them over a little bit, right? To wake them up. Yeah, you guys all have that one brother, sister, or family member like that, right? I know somebody. All right, now let's talk about Broca's, and this is cool. Broca's area allows us to have that understanding of spoken speech, right? Now, the crazy thing is, all of our language, whether it's Mandarin Chinese, whether it's Indonesian, whether it's Spanish, whether it is, right, Punjabi, right, anything, all those languages are all within a very narrow frequency. Very small frequency of sound, meaning that the sounds are very similar. So if the sounds are similar, how is it so that we can understand different languages from these similar sounds? Well, the crazy thing is we've trained our brain into this, right? So when you have the sound waves hitting your tympanic membrane with a set frequency, it causes action potentials that our brain then turns into a specific language, right? It's up to this area of the Wernicke's for you to train to understand that spoken language. It's usually found on the left side, but it can move over if you have a stroke on that left side, which is kind of crazy. Now, there's Broca's area that gives us motor speech. Right, what's motor speech? That's you talking, right? That's motor speech. How do we activate the motor neurons? So then when I say the words, it sounds fluent and it sounds correct, right? So you do have this Broca's area that allows you to form the words in a very fluent, very, nice way, so that when you are speaking, native speakers can understand, right? You can even end the sentence with a little uprise, so you know you're asking a question, that kind of stuff. That's the Broca's right there, right? It allows you to put your tongue in the correct position, allows you to have emphasis on the correct words and the correct sounds and syllables, right? So we need both of them to have the proper language skills. Now, notice here, we don't have anything about written language here. We're talking about spoken at this point, right? Now, if you have a problem with one, usually you shouldn't have a problem with the other. If you do, take a look at how big and how much room is between these two areas. If you have a lesion, usually a lesion is a stroke, a tumor, or some kind of infection, all right? If you have a lesion that affects both areas, it is such a massive lesion that usually you don't survive those. If it's a stroke, you don't recover from it, right? So usually you have one or the other that's affected. Now, if you can choose which one, you would choose to have Broca's, right? Why? Well, with Broca's, you still understand what people are saying to you. The problem is when you're trying to say and answer their question, it just doesn't sound the same. It's like having my parents who moved to America when they're 50 years old, 40s, right? And so what happened is, now that, because they've been living in Indonesia so long, they have very, very broken English. Even after all these years, right? They have that harder time expressing themselves in English. And when they talk, it doesn't sound like a native speaker. It's kind of like how I am when I speak in Chinese, right? It sounds terrible, right? So eventually people understand what I'm saying, but in the process, I keep really, really making bad statements accidentally. Or I go order in Chinese and I have 8 orders of dumplings instead of 8 dumplings, right? That happened, right? So that does happen from time to time, and it's because, right, I was not brought up with speaking Mandarin as much as I was other forms of Chinese. So my Mandarin and the way I produce the sounds in Mandarin are different. Now, my English, and somebody actually wrote that on my review, right? Somebody actually wrote that my English wasn't good. I was very devastated. I'm like, I don't know what you're talking about, right? My English is pretty good, right? It might not make sense sometimes, but it's still going to be pretty fluent. So Broca's right here means that you can't, right? When you have a problem with the Broca's, it doesn't sound good, but you still have Wernicke's. So you understand the speech when somebody's talking to you. That's an important one, right? You can also, and you can always, with Broca's, doesn't sound good, but eventually you get it out. My parents, when they're speaking English, eventually people understand what they're saying, right? It might take longer, but they understand. When you have a problem with Wernicke's, your understanding of spoken language is completely gone. Somebody tries to talk to you, all right, and we're talking about your native language, you don't understand a single word they're saying. At that point, you can imagine how frustrating it is to everybody, including yourself. Because what happens is, You can read everything fine, and when you read it, you can say it perfectly fine. But it doesn't make sense when you say it. It's like me, right? It's like any of us who doesn't speak Spanish, right? You can read Spanish. It's one of the Romance language. So when you read it, it's got the same alphanumerics and everything, right? And you can practice it, so then you can almost sound like you understand what you're talking about. But if I was just to read it over and over, I don't understand what I'm saying, right? But it might sound good if I practice, right? Now, I hear this all the time with my daughter and her friends listening to their Korean songs. BTS, right? They start singing their Korean songs and like, do you understand what you're saying? No. So you're just singing in a foreign language, you don't want to know what they're saying? Okay, right? I'll take that, right? So that happens. You can say it properly, you can even sing it perfectly, and have no understanding of what you've just said, right? That can happen when you have a problem with Wernicke's and Broca's is still intact. Now, there are other things that are crazier, right? I remember a few years ago, there was this person, right, that was a Spanish speaker. In America, Spanish speaking throughout their whole family, right? They got into some kind of brain trauma. I believe they had some kind of infection where he went into a coma, right? And then when he woke up, he only started speaking Persian, right? There's no Persian in the history, never know anybody that spoke Persian, right? But he understood and he spoke it fluently, right? And what happened? Nobody knows. And they had a Persian speaker, the guy, that's Persian. He's talking to me in Persian, right? And he couldn't speak his normal language. Couldn't speak Spanish, understand it at all with his parents. His parents are like, all right, what's fucking wrong? Right? Like, why did you learn a language, right? Why are you messing with us? Right? So they had psychiatrists going in there that's put him in CT scans. Everything was normal, right? And he just woke up with the ability to speak in a foreign language and understand it understand everything in a foreign language, right? So there's not a foreign language that he had any previous, contact with at all, right? So he woke up with it, and then over the course of time, right, through many months, he lost that ability, and then learned to speak his native language, Spanish again, right? We don't know how that happens, but that does happen every now and then. And you're like, dang, all right, if we could do that, can you imagine if you could, I don't know, go to sleep for a couple days and just be like Neo in the Matrix, right? And you wake up and you just learn another language, right? That'd be kind of cool, but that'd be kind of scary as well, right? But we know that there is some way that actually happens, right? Now, our way of kind of making it happen voluntarily and causing that effect, that's going to be many, many years until we get to that point. But it does happen. Now, before we end, this stuff right here with the PET scans, what do we do is this, right? How do we know this area of the brain has that function? Number one, we can put you into surgery and wake you up. People don't choose to have surgery as part of a trial, right? So that is one way we have done it, where somebody has to have surgery in the brain. So when in the process of having surgery, because they have a tumor in the brain, they put you into deep sleep, all right? And then when they remove the skull cap and actually start doing surgery in the brain, they actually wake you up a little bit, right? So as you wake up, because I've always heard in the regular press, layman's press, that the brain has no pain receptors. It doesn't. It has no pain receptors. Now the dura mater does, so does all the meninges. But once we kind of wake you up a little bit, we've gone past those, right? And we pretty much have into the brain itself. Now, in the brain, we know brain cells are very important. So we only want to destroy the tumor, remove the tumor, leaving more good brain matter intact, right? So what they do is they allow them to wake up a little bit, and then they stimulate certain parts of the brain. As they stimulate certain parts of the brain, sometimes they stimulate parts of the brain for memory. And right then and there, they relive a memory 10, 15 years ago, right? And they will mention it, right? Because they do want you to tell them what you're doing, right? So at certain times, they'll say, okay, oh my God, I smell this thing, right? And obviously they're in OR, not smelling anything, but they will so right? Describe what's occurring with that smell and that day to the intimate detail. They're reliving that memory because we reactivated that pathway, right? So we know memory is found in a series of pathways, right? That's one way we can tell where certain functions of the brain resides. Another way is doing a PET scan, right? So we infuse your body with irrigated glucose. We know about 20% of your cardiac output goes to your brain. So, a fifth of that glucose should go in your brain. Now, your brain then only uses glucose as a fuel source. So the more active a certain region of the brain is, the more glucose it uses up, the brighter it glows during that activity. That's what they're doing with these PET scans, right? So what they do is they show you a picture and they wheel you into a CT machine, right? And then they project a picture and ask you to describe and to say the name of the picture of what you see. So usually they have something easy, like a red car or a blue car, right? So what happens? When you first project up that blue car's image, your visual cortex brightens up as you're trying to interpret that stimulus. Then you have to figure out what it is and how to say it. So that car, that blue car, right, you need to find the right words in your language. So your Wernicke's brightens up, right? As you come up with the words, now you have to make sure you can say it properly. So your Broca's brightens up, right? As you're trying to have that planning phase on how to say the words. And then, as the Broca's brightens up right here, you activate the motor cortex. So then you can then eventually stimulate the motor neurons that goes to your mouth and tongue, so then you can say the words properly. It's pretty cool, right? In terms of the right and left cerebral cortex, you guys have heard of people being right brain versus left brain, right? So the right side of your brain controls the left side of your body. It receives sensory input from the left side of your body, right? I think we all kind of understand this already. If you have a stroke on one side of the brain, the opposite half of your body is affected. Right? Now, this is a part that's kind of cool. Left versus right brain, right? Left brain people are like your Spock character in Star Trek. Logical, to the point where, right, they're almost no fun at all, right? So what happens is these are your mathematicians, right? Your scientists, your logic machines here, right? Now, the good thing is we're usually not one or the other. We can be dominated, one-sided versus the other, but we all are different parts right here. Now, you can also be a genius on both sides. We have, at this point, really, really emphasized STEM, right? To the point where I think at some point we have kind of, ignored a lot of the other things that are important. Arts, languages, right? Those are important. History, those are all also very important, right? It can't all just be science, right? Even though I'm a scientist, I can even tell you that, right? Even though I can't play any instrument to save my life, right? I also know arts and music are very important. So when I mention that you can be a genius in mathematics, right? At this point in our culture, we think that's like the only genius there is. But there are a lot of geniuses around, and they don't all have to be, right, computer geniuses here. We have geniuses that are able to have greater musical abilities. Are you telling me that Mozart at the age of 6, writing his whole concertos, isn't a greater genius than somebody that can, right, produce mathematical findings, right? Have you ever tried to read a concerto, right, and look at an orchestra? Because I barely even look at an orchestra, right? Remember, no musical ability, right? So what happened is you see them and you hear all these instruments coming together. And then people have asked these musicians before, right? When you're writing these concerts, how do you write it? Do you write them for each individual instrument? Or do you write them all at once? And then you break it apart, right? The great ones, they just write it all at once. Somehow they're able to see how each instrument, each sound from the instrument accompanies the next one. So then it completes the whole concert when they're all entangled together, which is crazy at the age of 6, right? So that's a genius, right? So yeah, you can have a genius quality in each of these. And I want you guys to understand that even though we're going to be scientists, right, they are so much more than just science or math and technology, right? I know I don't have this on here with brain waves. Just important thing I want you guys to know about brain waves is simple. It doesn't stop, right? Even when you're asleep, there should be some brainwave activity. That's it, right? We don't have enough time to kind of talk about it too much, but you know, if you look at something like beta waves right here, where's my beta wave? Right here. All right, how it oscillates back and forth like this, right? That's a brainwave of concentration, studying, right? So this is a brainwave pattern that we want to achieve when we're studying. Right here, right? But there should be always some brainwave activity. When you're asleep, you have real weird brainwave activities. Right here, right? So, have you guys ever heard of REM, rapid eye motion? Have you guys ever seen REM? Right? I want you guys to try this next time. Right? With your significant other, right? Especially if they're sick. This is when you really see it as well, because right, when you're sick and you're asleep, you really need that real restful sleep, that REM sleep, right? You will be able to, you know, sometimes see their eye just twitching back and forth, right? That is that rapid eye motion sleep. And you can see it, and right? The weird thing is they're like this, and you know, their eyes are closed, their lids are closed, but you can see something moving back and forth. That's a REM sleep they're having, right? As we get older, it's harder to achieve REM sleep, and we will get out of REM sleep faster, right? So your parents become so pissed at you, right? All right, so the last things that we'll cover, we're almost done, is memory. So know these type of memory. I'm not gonna ask anything about REM sleep or anything, all right, or even brainwaves, just not enough time. Memory I will. Why? Because it's highlighted, right? So when we're looking at the memory, we have three main types: working, short-term, and long-term. Working memory is one we don't even think about, right? It is that working memory of when you're reading one sentence in a book, you remember it, so when you read the next sentence, you understand what's going on from the previous sentence. You can imagine if you have no working memory, you read a sentence, you completely forgot what was the previous sentence, right? Kind of like AP class, right? So what happens is when you have one sentence and then working memory allows you to link that previous sentence with a new sentence you are reading. So then you can understand the paragraph, right? Then you can eventually understand the whole page. So that's working memory. It's kind of there, so then you can refer back to it in real time. Short-term memory is kind of different. Information retained for a few minutes to for a few seconds to a few minutes. So that's what's happening when you are cramming right before an exam. It's like Dr. Lee going in, opening the door and says, oh, I have to get something printed, right? You have 10 minutes to kind of review, and everybody opens their book real quick and start reviewing real quick, right? What happens? Well, that short-term memory, right? What happens is it's easily lost. So if I take more time, or, right, what happens, I come back, you're putting things away, and now a few more minutes have elapsed since you have that the facts in front of you, right? The few minute of lag might be enough for you to completely lose that short-term memory. So short-term memory, right, can be beneficial in certain times. All right. One way, you forgot what your Roman numerals look like. So you know what the optic nerve and the olfactory and everything, the order, but right before the test, you want to look at it. So you write one olfactory, two optic, you write it down. And then when you do the test, you rewrite it. One olfactory, two optic right away. That's one way working the short-term memory can be effective. Right? The reason why is because you are making something concrete from it. Long-term memory is when you keep using that short-term memory and you start adding it to experience, right? So instead of talking about just what a T and B cell is for, right? When we talk about immune functions next semester, now you're talking about, all right, T and B cells. Oh, right, I remember watching this movie where this guy was in a bubble and they have this, this order, where they had no T and B cells, and you can link that up to that memory, right? When that happens, then you have this decorative memory and retention of facts, right? Or God forbid, you can link it to something that happened to you or your family. One of the things that did happen in my family was that my cousin had a boy that had adrenoleukodystrophy, right? An X-linked recessive fatal disease, a combination of which is very similar to muscular dystrophy, right? Where they just stop being mobile and they go into a comatose state. The worst thing about it is they go into a comatose state for years before they die, never awakening, right? So when I learned that, my cousin with her son that had this, obviously, I'm not gonna forget that disease anymore, right? So there's an added kind of stressor of having some kind of emotional link to it, right? That helps put that condition or that fact down into long-term memory, right? So it doesn't have to be that dramatic, right? But if you make it into something else you can link it to, right? That does happen. You can increase the probability of putting that short-term memory, short-term fact into long-term fact. Now, this is also the reason why I don't just want you to read, right? I want you to think about it, right? Think about how things are occurring here and play it around in your brain over and over as you think about it. That increases a chance of putting any of those facts into long-term memory. And what we found out is once it's in long-term memory, even though some of them are damaged or can be lost through time, right? Some of the long-term facts you're not going to remember throughout your lifetime. The good news is, if you don't remember it, you knew it before. And what we found out is even when the actual neurons die off because of a stroke, they are actual figments that are still present. So that all it takes is to reread that fact a couple times. And then you will now form new networks much easier, right? So this is pretty good, this decorative long-term memory. Now, the one we don't usually lose is a procedural one. How to ride a bike, how to drive a car, right? So those are more procedural long-term memory. Those usually don't get lost with time. Now, that doesn't mean you're just as comfortable, all right? When was the last time you guys rode a bike? Anybody within a couple years? And it's like once you get your car, right, you become independent, you just don't ride your bike anymore, right? That's what happens, right? Now, I want you guys to, if you have a chance next, well, if you have kids, you probably will, right, to ride a bike. When you ride your bike, understand you're not going to lose the ability to ride a bike, but boy, does it seem a lot faster now, right? When you go on it, you go much faster than you think, right? And then you're just, you don't lose it, but you're still not going to be as good right away. So just a little kind of warning if you guys ride a bike and you haven't done it in a while. All right. That'll be the last thing we cover. Let's take a break.